So we're going to keep counting things. And remember, you're always free to write every possible outcome, right? You can make a list. So for example, problem 4, how many even two-digit positive numbers are less than 50? Well, here I made a list for you, right? You can make that list, and there they are. But some problems are just incomprehensible, because what if I change this to a three-digit positive integer that's less than 950? It becomes a big task to write all these options out. So again, you're free to write all the options out that are available, just based on your gut instinct. But it can become daunting, overwhelming, and you could make errors, especially when you have a lot of numbers to be dealing with. So I'm going to rely on math. Now, I want a two-digit number, so that means I have two spots. I have two slots. And again, this is not us guessing and picking. This is us counting how many options are for each spot. Let's start off with the easy one. It is even, right? So, this is the ones place. Taking it back to third grade. And this is the tens place. Now, even numbers end in what kind of numbers? Even numbers end in 0, 2, 4, 6, or 8. Well, how many options is that? Now, before you think, Mr. Rover, 5 is an odd number. We're not representing an even number. We're representing the options. We're saying there are 5 options for this position, because an even number ends in 0, 2, 4, 6, or 8. That's 5 options. Now for the tens position, what are my options? Well, let's see. This number doesn't have to be even. It could be odd. Okay, because this number doesn't. I could have a number like 132, and that's even, and it only is even because this is the only number that matters. Okay, now that's irrelevant to us because we want a two-digit number. But my point being that the only spot that predicts if this is even is this spot right here. Well, I want less than 50, so that means that 0, 1, 2, 3, or 4. However, if I can't pick 0, 0 is not an option. Because if a number is 0, 2, for example, that's not a two-digit number technically. Okay, that's expressed as a 2. That's a single-digit number. So 0 cannot be an option for my tens position. That leaves me, my options could be 1, 2, 3, or 4. That's 4 options. Okay, so product rule, 4 times 5 is 20. And if you were to count all these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 options. So what the answers that we're getting is not requiring us to write out a list of every possible outcome. It's just saying, hey, there's going to be 20 outcomes. Deal with it. Okay? Locker combinations. So imagine that, a dial combination type of lock with numbers from 0 to 35. And you're pretty sure that a person's combination has 3 numbers and that each number is different. Okay, and all the options from 0 to 35. So first, let's ask the question, how many slots am I making? So how many little tic-tac, little spots am I making for us to put the options in? Well, how long is this combination? Okay. And how many options do I have, for example, for the first spot? So when I'm turning this combination lock and I'm turning the dial, how many options do I have for that? Well, it's from 0 to 35. So that's 36 options. It's not 35 because 1 to 35 is 35. 0 to 35 is 36. Okay. However, let's say I pick a number and I go to it. Can I use that number again? Well, we said each number is different. So if the number is 3, let's say the combination is 3, 15, and then 8. Well, okay, I just went to 3. That means I can't use it ever again. So that means I have one less option. And now I went to 15. And I can never use that again. So that means there's one less option. Okay, so each time there's one less option because I already picked one. So that's 42,840 possible unique locker combinations. So it would take you a while to do what we call brute force, meaning you would just try each one out, over and over again. Okay. One of the cool things about knowing how to count, quote unquote, is you can see if advertising is false, or it'll actually help you with your advertising, because then you can actually brag about how many options you can offer. So Pan Express, for example, at any given time they've had up to 18 entrees available, and an entree would be like orange chicken, barbecue, broccoli beef, egg rolls, etc. Okay, and then 5 main sides. Okay, they always offer you fried rice or chow mein, but you could get steamed vegetables. There is white rice, and then there is that stuff called brown rice. Okay, now a 2 entree plate comes with a main side, and then it has 2 entrees. So one slot represents the sides. This one represents sides. I mean, literally, when you look at the Pan Express plate, it has compartments. Okay, and only certain things can go into those compartments. Okay, so the first compartment are your sides, and then you have entree number 1, and then you have entree number 2. And the nice Pan Express worker says, what would you like for your side? And how many options do you have for your side? Okay. You could say, I want orange chicken. Nope, you need a side first. That's one of your entrees. So how many sides, options do you have? There's 5 side options. You're only choosing one side, but you have 5 options to choose from. Okay, then the Pan Express worker says, great, what will be your first entree? Well, how many options do you have? Right? So you say, orange chicken. Duh. And then they say, okay, what do you want for your second entree? And then you see a sign that says repetition is allowed. And you're like, orange chicken. Okay. And you multiply those. That's 1620 possible ways to get a 2 entree plate. That's pretty interesting. I mean, you could theoretically eat a couple of years at Pan Express and get a different plate each time. Huh, go figure. What about a 3 entree plate? Oh snap, they call it a bigger plate now, I think. 1, 2, 3, 4, right? This one represents a side. This is entree number 1, entree number 2, entree number 3. You get the idea. How many options do I have for a side? 5. How many for the first entree? 18. And then if I can pick orange chicken again, can I? Yes. And if you can pick it again, can you? Yes. Okay. And you multiply all those out, and that's how many possible 3 entree plates there are. Now, does the order matter in which the entrees are ordered? Well, we'll talk about that when you get older. Okay. But I want to just throw that out there to kind of start getting you to think a bit. So, repetition was allowed, but let's say you get a stingy franchise owner that says, no, you can't do that. You can pick your side, but you can't repeat orange chicken. So if you pick orange chicken here, you can't pick it anymore. Well, that means I have one less option to choose from, right? And all of a sudden we have less possible ways to order a 2 entree. For your summary, problem 6 was calculated by allowing repetition or choosing the same entree multiple times. So how would problem 6 be different if repetition was not allowed? Right? Like if you think about problem 5 with the locker combination, repetition wasn't allowed. So what happened each time when I picked an option I had less options each time. Take some time. Use some words. Summarize. Orange chicken.